Hello, in this video we're going to talk about how to solve a system of equations using the elimination method when your problem is not set up for you. Alright, so on our screen we see our example problem, and what we would love to do is we would love to add these two equations together, but neither the x's nor the y's are going to cancel out. So we need to decide which variable we want to eliminate. It doesn't matter which one you choose, sometimes one is easier than the other, and how you know that is with your math facts. So as I look at both x and y, what I am looking for is to see what coefficients, if any, go into the other number. So I would look at -2 and -7, and in my head I'm going, okay, does 2 go into 7? No, okay, so that's going to take a little bit of work. Then I would look at my y's. Okay, I got 1 and 3. Perfect. 1 goes into 3. 3 is a multiple of 1, so now we can eliminate our y's a little bit easier compared to our x's. So what I want to do is I want to multiply the entire bottom equation such that when I add it to 3y, I get 0. What I am going to multiply my entire bottom equation by is -3. That way the value will be the same, but the signs will be opposite. So off to the side, I'm going to go ahead and do that multiplication. So -7x times -3 is 21x. Y times -3 is -3y. And 19 times 3 is 52. Now, this is kind of an error prevention thing. I'm also going to take that other equation and I'm just going to write it on top of this equation so that everything that I'm about to be doing is nice and organized and aligned for me. Now that I have my problem set up, we can look at that and go, yes, my y's are going to eliminate or cancel out. 3 minus 3 is 0. So I'm going to go ahead and add these two equations together, top to bottom. When I do that, -2x plus 21x is 19x. 3 minus 3 is 0, or 3y minus 3y is 0. And -19 plus 52 is going to be 38. Again, I would solve this equation by using my inverse operations. And we find that x is equal to 2. Now, like before, I'm going to substitute x equals 2 into one of my two equations. I technically have 3 choices: the 2 original problems and the third manipulated equation. The best choice, and I say best just because it requires less work, is going to be one of the other 2 original equations, and I just say that because those numbers are smaller. I could substitute in 2 into 21x minus 3y. I'm not going to. Let's go ahead and substitute that into the top equation. So we'll have -2 times 2, and then the rest of that. And I would go ahead and once again solve this equation. I multiply my -2 and 2. I am now doing my inverse operations. And I get y is equal to -5. Okay, and then to end my problem, I will write this as an ordered pair. I'm going to put a box around it so it's really easy to see what my solution is, and accidentally erase it. There we go. But the solution to this would be 2, -5. Again, what you're seeing happen is we make the problem a little bit more complicated, and how we're doing that is by needing to multiply one of our equations by a value. We could go back and eliminate the x's instead, and the only thing that would be different is that I would have to multiply both equations by a number to get them to eliminate.